Hey guys, Dr. Brown here, and tonight we're working a differential equation, an exact differential equation, and this came by request out of some guys at Tarlock State University. So bear with me while we go through this and try to explain what an exact differential equation is. As you're working your diff-E, equations take on various forms. In this case, m of xy dx plus n of xy dy equals 0. That's the form. Okay, what is m and n? What does that mean? I'm going to explain the process with the simplest diff-E that I can do this with. I have an equation, y dx plus x dy equals 0. What's associated with dx, we're going to call that m. So m equals y, okay? N is the term associated with the dy. So in this case, n equals x, okay? Now, I'm going to take the partial of m with respect to y. So the derivative of y is 1. I'm going to take the partial of n with respect to x. The derivative of x is 1, okay, so 1, the derivative of m with respect to y equals 1, and derivative of n with respect to x equals 1, so this partial and that partial are equal, so we can say this is an exact differential equation. Now what that means, since they're equal, there is some function of x and y such that the partial of that function with respect to x equals m, and the partial of that function with respect to y equals n. That would be of that function. So our goal is to try to find that function from this differential equation. Hopefully that's as clear as mud. Okay, all right. I like processes. All right, here we go. Step 1 was you need to identify m and n. Step 2, you need to take the partials and determine if it's exact or not. Okay, step 3. Now you can do this one of two ways, but it's going to make the, let's assume, it's an assumption here, let's assume that f of xy, some function of xy, equals the integral of m dx plus g of y. Now I have an m is y. So we have the integral of y dx plus g of y, and this g of y is my constant of integration, okay? But we're going to do something with it here in a moment. If I integrate y with respect to x, y is just a constant, so I get xy plus g of y. Not g of g, but g of y. Okay. So that is my f of xy that I'm thinking of. All right. Now then, let's work a few more things down here. So that's step 3. We're going to call that one 3a. That's important. We're going to come back to that one in a moment. Now step 4, I'm going to take the partial of f with respect to y and set that equal to n. Okay, so let's take the partial of this equation with respect to y. So the partial of xy, x is a constant, so I end up with x plus g prime of y. And that equals what? Equals n, and n was x. So now I'm trying to ultimately, back to equation 3a, figure out what g of y is. If I can do that, I have solved for f of xy. So let's solve for g prime of y. So if I subtract x from both sides, Those cancel, so I have g prime of y equals 0. All right, let's go up here. Well, heck no, let's do it right here. So now, g of y, remember I'm trying to solve for this guy right here, g of y equals the integral of g prime of y dy, and that equals the integral of 0 dy, and that equals c, the constant of integration. So let's take this equation right here. So I have x, y plus g of y, okay, and g of y was c, so x, y plus c equals 0. Remember, all of this thing equals 0. So it could be x, y equals negative c. Okay, so we have some function now. xy plus c equals 0. Well, hey, let's take the derivative of that and see if we end up with the original function. So what's the derivative of xy? So that's first one, x times derivative of the second one, dy, plus y dx. Derivative of constant is 0. Derivative of that 0 is 0. So x dy plus y dx. X dy plus y dx equals 0. Hey, that was my original differential equation, and I used this process to come up with what the function of xy actually is. Okay, but that's on a very simple problem. Now I could have, remember I said I can do this two ways. I could have said, I find x, m and n. I take the derivative of m with respect to y, and the partial of n with respect to x, determine if they're exact. But at that time, I could have said, I'm going to assume that the function of xy equals the integral of n dy plus h of x, and gone through it that way. You get the same results. And sometimes that's important when you're looking at m and n, and maybe one of them is some crazy something that, whoa, wait a minute, trying to integrate that might be a difficult problem, but later taking the partial derivative of it might not be so bad. So that's something to think about. Okay, now let's work this other problem. Let's step up our game here just a moment and see if we can work this guy. All right, I have 2xy dx plus x, the parentheses of x squared minus 1 dy equals 0. What to do? Step 1, what is m and n, right? M equals 2xy. It's the term associated with dx. N equals x squared minus 1. It's the term associated with dy. Okay? Now, you'll notice in a lot of textbooks, they'll say m of y. And what that means is take the partial of m with respect to y. So that's another way of writing that. Okay, 2x is a constant. So the derivative of 2xy is 2x. Okay, now I'm going to take n of x, which is the partial of n with respect to x. Derivative of x squared is 2x. Derivative of the constant 0. So 2x equals 2x. So this is exact. That means there's a function out there that the partial derivative of that function with respect to x equals m, and the partial derivative of that function with respect to y equals n. Hopefully that came out okay. All right, 2. That's number 2. Let's determine if it's exact. Number 3. Okay, now let's assume there is a function f of xy, and it equals the integral of m dx plus g of y. So m was 2xy. So I'm taking the integral of 2xy dx plus g of y. The integral of this, I'm going to raise, this is to the first power, so that becomes 2x squared over 2, raise it to the first power, or second, by the power by 1, then divide by that, what I ended up with, times y. That's a bad y. That's not any better. Okay, those twos cancel. Plus g of y. Okay, that's what I'm thinking f of xy is. Now then, step 4. I'm trying to take the partial derivative of f with respect to y, set that equal to n. Remember, I'm trying to figure out what g of y is. That's my goal as I move forward. All right, the partial of x squared y with respect to y is x squared plus g prime of y, and that equals n, and n is x squared minus 1. So if I subtract x squared from both sides, those cancel. So g prime of y equals -1. So step 5, what is g of y? That equals the integral of g prime of y dy, which equals the integral of -1 dy, and that's minus y. Okay, so I'm going to take and plug that negative y into, I should have marked it 3a, sorry. I have x squared y plus g of y, and we'll say that equals 0, and g of y is -y. So I have x squared y minus y equals c. We'll just call it c, my constant of integration. Okay, now if I'm trying to ultimately get to y equals something, I can factor out y, that x squared minus 1 equals c. So y equals c over x squared minus 1. Now if I have an interval associated with this function, it can't contain -1 or 1. So it could be minus infinity all the way up to almost -1. It could be greater than 1 up to positive infinity, but it could also be in between -1 and 1. So there's 3 intervals for that function. Now let's go back to, where were we? Right here. Now if that's the function, I should be able to take the derivative of that with respect to x and get m. In other words, the partial derivative with respect to x plus partial derivative with respect to y should give me this original function. Hey, let's try that. All right, let's take the partial of this, partial of f with respect to x. So with respect to x, that's 2xy, and the rest of that's 0. Okay, now and that equals m. It should equal m. Oh, m, 2xy. So far, okay, let's take the partial of that function with respect to y. Okay, so with respect to y, that should give me x squared. Derivative of this is 1, minus derivative of that's 1. X squared minus 1, and that should equal n. And it does. So in my differential equation, 2xy dx plus x squared minus 1 dy equals 0. And that was the original function that we had when we started. And that, my friend, is how to work an exact differential equation. Obviously, there's some really complicated ones out there. Have at it. And I'm sure we'll be working some more. Why are we doing this? Together, we're trying to build a better tomorrow, and do that how? Do that through math. Keep studying, guys, and we'll talk to you next time. Thanks.